Yeah, so there are more people on the way, so I'll
Oh no.
talk slow, right?
I can talk
so-
really slow.
I know a lot of folks have met Lindsey before. You probably worked with him. If you haven't, this is your chance. You are now Lindsey's new best friend. You'll hear in a lot of talks, we're like, oh yeah, we just get Lindsey to do that.
The center of the universe.
Okay. Part of the reason is because there is, when we're trying to figure out funky little parts or like, hey, I want to make a something or something, he's got the brain for figuring out like, okay, I'm going to make this little...
I wouldn't call it a brain, it's just matter.
We wouldn't either, but we still love you.
Right. For making, he's got some brain cells for making this part function and work, all right?
And they fire once in a while.
Yeah, and he does have 3D printers and all that to actually make it happen. But...
And other shit.
And other shit. When we were talking about what to do for a talk here and some of the questions I get into the website is like, okay, if I'm designing a kite and I'm going to start framing it, I'm going to start doing things like, how do I figure out parts? One, how do I know what parts are out there, right? We could go old school and use vinyl tubing and do that. Or like, how do I design a part? And then how do I make the part? All right, so kind of the whole gamut. And we're going to try and, I think Lindsey's going to try and cram all of that in there.
Or how to design and build booths. Well, that's a project right
that's
now.
A project. That's random. All right, so with that, Lindsey, I'm going to hand it over to you.
Oh no.
Yeah.
There was a drawing right here.
Lindsey, focus.
Oh, I am. Okay. So, just a little bit about me if you don't know me. I've been a maker all my life. I mean, literally all my life. As in Ronnie and Scott Hampton, we were all model car builders, and you know, so our brains kind of connect easily. And Ronnie and Scott, we collaborate well together. Oh, and Bazzer too. Pardon me, but you know.
And sometimes me.
And you, and Paul, and Ron, yeah.
Forgetting your key collaborator behind.
Well, yeah, and Ron DeRue. Anyway, okay, and as you can tell, I probably didn't prepare anything. No, it's all in my head. So, I've worked with a lot of you, but I haven't worked with some of you. And so, primarily, what I'm going to talk about is creating 3D printed parts, or they can be machine parts because I can do that too, but I don't anymore. And then and how they apply to designing a kite, or how you take the design of the kite and then create the fitting. And that's where Ron Gibbion comes in, and Scott Hampton, because they have a kite that have built before, but then I simplify it. Take, for instance, the Emu that had how many little 56 little feather things, and we got the time of assembly down from what to what?
With the wife, it's down to less than half an hour.
Less than a half an hour now.
Knows how to do it.
Right, but that's with snap-on fittings, and then with Ron, I send him stuff and then he uses it in a kite, and it doesn't have to be particularly for Ron. So Ron adapts things, in this I'll show that, taking a fitting that I've already built for a kite that we built, and then
a model idea.
Yeah.
We have designed some parts together.
right.
That is strictly our for myself.
Oh, absolutely. And in the Humble Bumble, for example, you know, I get Scott and I will chat on the phone. Actually, it starts off with a text message. Scott's good for about 2 or 3, and then he calls. And
It's a lot easier to talk.
oh yeah, and then what I'll do is that this is for the Starlight, Ronnie's kite, and I'm got my sketch pad in front of me, and we're talking, you know, and I'm writing down the dimensions and I'm sketching, you know, and I pretty much have the part the concept of it, the base of it done by the time I'm finished with our conversation. And then I'll go into my CAD program and 3D model it. And then about 10 iterations later, you know, you get the fit, because these are custom parts, so we don't rely on glue. You've never used glue, well, except to hold a rivet in place, but not to hold the spar on, the spar into the pocket. And Scott, you don't glue anything on anymore because, well, Scott does in, we've done quarter millimeter increments on pockets, hole size for the spars, yeah. So tiny little fittings, and I've got a 1.5, a 1.75, a 2.0, and all these, and then, you know, if it fits, it fits. But he just wants to grab and go. He doesn't want to have to fiddle. So, if I'm rambling, just direct me.
Just tell him to focus.
Focus. No, you know what that, yeah.
Good.
So,
Love you, Lindsey.
and then, but designing the part for me is the easy part, and for others it's going to be the difficult part. I've been using computer-aided design since '85 when I bought my first real computer that had it didn't even have a hard drive yet. It had 2 floppy drives, but anyway, and it had a $29 little 2D CAD program, which I can still use. It still works really well. And AutoCAD built it and destroyed it. Anyway, that's another story. But anyway, so I've been going digital for a long time. And I started off in the late 80s with a 3D program, and it was just too complex. And then once the current generation came out, I played with Tinkercad. Anybody's played around with Tinkercad, know what it is? Well, it's an Autodesk product, and it's real basic, but it's maturing, let's say that, because it's coming up with some functions pulled from more sophisticated CAD programs. But it's still not quite like using a slate and stylus, you know, with a chisel. You know, my first laptop, actually my first laptop was my Etch-a-Sketch, but anyway, and then I use Fusion, which is an Autodesk product. It used to be called Fusion 360. And there's free versions that are kind of detuned a little bit, but it's really an amazing program. And I've been using it probably 7 years, something like that. And I still don't know what I'm doing. And I watch YouTube videos all the time. And that's the best thing. And when you're getting started in 3D printing or designing, that's where I would go. Be resourceful. Go to these videos. Watch this stuff. You have to watch out because there's some stuff that people think that they know what they're doing, and it's like, no! It's kind of like YouTube videos on building a kite. You know, a trash bag Delta kite. And they put the spars on backwards, but they never show the things flying. I've never, you know, some of these, they never show them flying. So that you have to be aware of stuff. But so I work it in CAD, get that dialed in, and I've been doing it long enough to know what the tolerances that my printer can do. And so I measure and build everything metric. Ronnie gives me inches, and I just, you know, convert it. And, well, not all the time, but on spar sizes, because, you know, an 080 and converts to, right. And, but 3D printers, if they're tuned right, I can get down to like a 0.02 millimeter difference in a hole size and feel it. And so, but then that can change, and I'll get into that with, oh, here it is, material. Sorry for the handwriting. or the lack of. It's the little bit of shaking that goes on these days. Anyway, and so once you have your part designed, and the other thing about designing a part is that a lot of people just take and rebuild a leading edge fitting, and God, anytime I say raise your hand. I'm trying to break myself of it. Rhonda just, and I want to do a like a dog collar with ChatGPT hooked up to it, and every time I say it, so then think of people I have Tourette's,
It's like a tick.
Yeah. So anyway, and I said that to myself coming up, and envisioned everybody raising their hand at the same time when I didn't say it. Yeah. Where was I?
I don't know.
You said you got down to 0.02.
Yeah, the tolerances. Having said that, one manufacturer of filament to the other. First of all, does everybody know how a 3D printer works and what I'm talking about? Okay, just envision a hot glue gun,
That's actually a good way of putting it.
controlled by a computer on an X, Y, and Z axis, the Cartesian method. And it's just like, you're drawing, and then it does it in layers. And we have the base layer, and then each layer, it builds up, and those layers can change the shape. And if you look down on it, say it was a circle, and it would be this, kind of like a topographical map. So that's all it's doing. And
Is it rough in there? Do you have to kind of shave that a little later or no?
no, I'll pass parts around. I mean, it's done. Even with the FDM printers, which is filament deposition modeling. So that's the pooping out plastics out of a string of plastic, a filament.
You pick the first dot on the bottom of the circle, right?
Here.
Yeah, and you follow around the edges of the circle. You pick some.
Yeah, what it does is that it's hovering. I print in about anywhere from 0.2 millimeter layer height up to 0.3. I can go down to 0.1, but every time you ratchet it down, it takes that much longer. So,
Let me one quick question.
yeah.
So can you program it so at a certain point you get 0.1, and then the next layer, like on those edges, you get, you know what I mean?
Can you
Do
program
you always do the same tolerance throughout, or does it change within?
I can change it within now because there's two programs that we're using. We're using the CAD program, and then we're using a second program called the slicer. And it takes the data from the CAD and it slices it into the layers. Okay? And I can control layer height through there. I can do variable layer height. I can control fan speed to cool it. I can control temperature. I can control speed at each layer or a portion of it, because there's modifiers now where I can take a sphere and say on the spherical shape on the inside of that part, I can have it do some voodoo to it. I can have it not print and just leave a void, or I can change the infill. That's the other thing we do, is that we put infill in so that it's not solid. Like this is a carbon fiber nylon part for the Falenas, and this has a little bit of infill in it, but it also comes apart. It's a sliding dovetail, so that we don't have to take the Falenas apart anymore. And so it's pretty light. Anyway, that's carbon fiber nylon. That's really strong. So you have the slicer doing its thing. You got the CAD. So you need to get your head wrapped around all that. Some people get it real quick. It took me a long time, because I sometimes work in circles, you know, and I chase my tail because I don't write things down. I'm not real scientific that way. I try to be, but then the squirrel appears and it goes away. So, materials. Ron Ortega brought this up just a few minutes ago because I just delivered or sent him his parts for Oregon Kite Makers Retreat. He's doing a 12-sided, it's a flat kite, 12-sided. It's about the diameter, about a 40-inch diameter. Yeah. Huh?
Colombian bandero.
Bandado?
Kind of like that,
Yeah. And I built 8-sided for him before, and with 3mm carbon. And you use tubes on the first 8? Yeah. But this one, I recommended the solid, and this is the one for the 8 spoke. So, and this one is, that's the final one. Trying to remember. This is out of a semi-rigid TPU, which is a thermal. It's a rubber, but it's a very hard rubber. And but the company doesn't make that anymore because the supplier of the chemical, the resin, quit making it. And it's like, wait a minute, it's one of the most popular, and trying to find a replacement for that has been really, really tough. And so I went with, tried out the next thing that has about the same durometer or the hardness of it, and it's PCTPE, which is a nylon rubber blend. Well, it works really well, except that it is a little too flexible. I'll pay, these will be up here for everybody to look at earlier or later. Yeah, I do. The newest one. Oh, and then you can pass these around. This is the example of what the infill is.
Oh, okay. I'm sorry.
And go ahead, pass that one around. I think that it looks like a pan flute, you know, or a pitch pipe. What is it? Yeah.
That's 8, that's 12.
Yeah. No, that's 16.
That's 16. I have a 16.
Pretty close.
Lots of straight lines, make a circle.
What's that?
We were talking about after the design concept. This was our Tommy Tomo.
Oh,
originally.
perfect. And that's the new. Great. Okay. Okay, so this is the newest. This is for his 12-sided. The white is the PCTPE, and you can flex it,
I'm asking because I'm getting ready to make a
but you can hold it up and you can see the infill. Even if I put solid infill in it, it still flexes. But I put metal rods, and I test all my parts. So because these just don't break unless there's something really wrong with it. And but that's nylon and a thermoplastic blend, but it does have a little flex to it. Now,
I like the flex of that one, Lindsey.
well, that one you don't have.
The one that you made.
Yeah. So this is what I sent him, and this is nylon, and this is not a bleached nylon. This is natural nylon, so it has a kind of a cream color to it. And he said that it flexes, and I can get it to flex a little bit, but when I made them, you dropped them and they sounded like a coin. And, but I put 1/8-inch metal rods in, and I can bend the rods. It won't break. But why he's getting flex is because nylon, this is a PA6, and PA6 is a real strong nylon, but it's hygroscopic. It sucks up water about like 15% of its mass. It'll absorb in water. And the first time I experienced that was my 1969 Cadillac Eldorado. And I was washing it. And I and I was going to vacuum the back of it in the back bedroom. Actually, is what the back seat was basically, right? And I moved the front seat, my driver's seat forward, and I had the steering wheel in my chest, and I went to put it back, and it wouldn't go. It stuck, you know. And I'm going, what the hell, you know? And so I called up the Cadillac dealership in Portland after I got out, because that was pre-cell phone, and I called in the service manager, and I said, what's going on? He says, just get underneath there. It's the cable. It goes through a nylon bushing, and the nylon bushing absorbed some water, and you have to just ream it out. And I'm going, it's plastic. He says, trust me. And I took it out, you know, and put some sandpaper on a drill bit and reamed it out, and all was good. Well, that was then. So what you have to do with nylon, especially PA6, there's PA12, which doesn't absorb moisture. It's down to like 1%, and but it's more, it's not as resilient than this. So what you have to do is you have to dry your filaments. And so I have a dehydrator, food dehydrator, and a spool of PA6 you have to dry for 12 hours at 70 degrees Celsius, and that's 100 and... Oh, come on. Oh, that's American. Yeah, I know.
Ask this one.
Oh, 70C Fahrenheit. Yeah. Well, it's 120. Yeah. Yeah, for 12 hours. And we do, yeah, because I have containers that I print from that are sealed, and then they have desiccant in to keep the moisture level down. I can keep it down to about 10% once I dry it, and then I print from that. But then there's other filaments like PLA, which is polylactic acid, and that is made from cornstarch, and it smells like maple syrup sometimes when you're printing it, and it doesn't. It's not affected by much other than breakage. I mean, it's a real stiff filament. It's kind of like glass. Glass is really strong until it's not. And sometimes it doesn't take anything to break a sheet of glass, as you probably know.
So if I could ask it, so you have to make it dry so it prints properly. What happens after you print it? How does moisture affect it being a kite flyer?
Well, the other thing...
Okay, so yeah, Lindsay, did you hear that?
How it affects the kite flyer? Oh.
You dry the filament so that you can print properly, but
right.
After it's dry, how does it react to moisture?
Well, it still absorbs moisture, because Ron has noticed that, because the parts that he has now that he's been flying here, he can flex a little bit, and this is still.
They flexed in the air.
Yeah.
High wind, which I really appreciated.
Right.
So you can build that. You can build that into your design.
Right, and the other thing is that you can post-process these parts by what's called annealing. Okay, and I can put it in an oven for 2-3 hours at, I think, 180, 200 Celsius, and then it starts cross-linking. Yeah.
Does the same printer work with all these different materials?
Yeah.
You don't have to get a separate printer?
Well, not necessarily, because all my the main thing on printers is that you need a hot end that melts the plastic. You need it to be able to go up to 300 degrees Celsius, because the nylons I'm printing at 265, 270, but like PLA you can print down to 110.
So as long as your one printer can go that high, you're good.
Yeah, and and there's so many printers out there. I've been using Prusa printers out of the Czech Republic since I started. Well, no, I can't say that, because I bought a Kickstarter one that was made in the. It's about so big, and yeah, I could have brought it in my pocket. No, but it did well. But in fact, did I make a cookie cutter for my first class?
Get back to the annealing there.
Yeah.
You're saying the molecules then of the nylon cross links?
Well, yeah, because we're slicing in layers, and layer adhesion is your friend. And moist nylon, you don't get hardly any layer adhesion, because what happens is that the filament actually boils. The moisture in it steams and spits. And this part, if it was wet, would have been like crystals all over it, just real crystalline in its surface. And you could take it and just snap it. But if you dry it properly, it works. And then you anneal it, and then the layers start bonding together.
Then you thermoset it, and then it doesn't really work with water anymore.
Well, it still is affected by water, but not nearly the effect. But it becomes more isotropic. You're right? Yeah, which is dimensionally strong in all directions.
All properties the same in all directions.
Yeah.
Yes.
Yeah, 3D printing. This is X, Y, this direction across it, and then Z's up and down. So it's your Z is your failure on most of when you're, yeah, because of the slicing and other material properties that I talked about, moisture, and just and it's getting easier because so many of the manufacturers now test filament, and then they provide profiles. So if you buy, say, an Overture brand of filament, they already have some presets for you. But I don't. I do that a little bit, and then I go in and modify.
So you, as the person that's consulting with the supplier and find out their needs, you kind of go through a mental checklist to come up with the correct settings and the correct filament to use. And I mean, you can't just pick something out of the bag. It's knowing the materials is what makes it different.
Well, yeah, knowing what the loads are on the kite too. That's the other thing is this little kite that Ron's making, granted it's 40 inches, but there's 12 spokes, so the load is transferred, it's not like 2 spokes getting the same load or 4, say, as 12. But, this isn't that big around, and the spars go in, 20 millimeters or so, 25, something like that. But it, I'd break the fiber. This is just fiberglass, but even carbon fiber, especially tubing. If you're going to use carbon fiber tubes in there, you better have an internal ferrule in it. Plug it with wood or another piece of fiberglass or whatever.
Dual thing from the
Yeah.
inside and the outside.
Yeah.
The part.
Yeah.
So the technology, though, allows us to go from this is our Tommy Tomo vinyl that would go this out the corner and then the bar. Then it wants to be taken together. Is that? And then Lindsey, so go ahead and explain that one, and I'll hold rods for you.
Yeah. So we were going to put one together, but it's a 90-inch tall kite, and it would be flopping all over.
So it goes like that.
Yeah. So that's the spine, and then
That travels up and out. And
yeah,
this
and then
goes up
these
and
go
out.
up to the corner and to pop the corners out,
But the bottom line is
and then these are
so that this can still be locked in. This is your spine.
these are the other spines.
Yeah.
Yeah.
Or the
The longer ones. Yeah, on each side. There we go.
So-
Okay.
So like that.
And you can find water with it too.
But the bottom line is he came up with this beautiful right here, and it's flexible, but
Yeah, and this is out of the TPU, which is the. Here, I'm gonna. So this is the TPU. This is. This is made by Ninja Tech, and if you look at the edges, there's some stringing in here, and I'll pass that around. And that's also caused by moisture. So TPU, if it'll also absorb moisture, not like nylon, but the drier it is, the stronger it is. And but if you start getting stringing, you know you've picked up moisture. It's just a little tattletale.
That's not considered rubber.
It is.
It is a rubber.
Yeah. It's a polyurethane.
But for me as an observer, because I got to touch his machine for a big project for a short period of time, and it was fun. But the concept of coming from a sketch or an idea and then making it, make it so, is just for me as a bystander a fun entertainment, especially with the back and forth and the banter and the bottom line is people don't care what it's made out of as long as Lindsey knows his stuff to come up with the right materials for that particular need. And that's where anybody can print things, but if they don't have the correct settings or the correct concepts in mind or materials on hand, you're not going to get the same thing. And so Lindsey will get calls or people will ask you, hey, can you send me your file? And he says,
No, and it. Well, I mean, because a lot of times, you know, I've got a lot of time in that tiny little part, but that's only part of it. It's that if it fails, I don't want to get blamed for it, you know. And but what this is for the tumbling cube.
Probably, yeah.
Yeah, and this part got reduced smaller, and I like printing little tiny stuff because it's easy. But this is real strong. I mean, it's not going to break, but I'll pass this around. But the other thing that I do is, if you look at this part in the oblique light, you'll see a couple little bumps on the sides, and those are a little ring inside there that's a tiny little bit smaller than the outside diameter of the spar, and it grips. And this one slides a little bit, but that's because it's a smaller tube. It's sized for this 2mm carbon, and you can't move it, but give it a twist and it slides. And let it set for a few minutes and it locks back up. And the reason I designed it that way is that, you know, you get a fitting that long, and typical injection molded parts are solid all the way through, unless they've spent more money to put a pin inside of it, and then the pin has to extract. Well, that adds on thousands of dollars. Yeah. And so with 3D printing, you can do stuff inside that you can't do. There's stuff that I can do that injection molding can never do, just because it's inside. Yeah. Yeah, the tensioners. Yeah, which are on that kite too. Anyway, so here you can play with that guy. Yeah.
So could you tell me like some things that you try to consider when you're starting to design a part? Like depth of how far that stick is going to go in, flexibility, size, weight. Like, what are some things you consider when you're designing a part?
Well, some of that, if it's for me, it's just kind of a TLAR thing, you know, just years of experience of, you know, what has worked in the past. Because I'm not creating anything new per se in that respect. I mean, you know, that an old fitting did. But the others is working with somebody else like Ron or Scott and Ron Ortega, wherever he went. So anyway, and just kind of figuring out what the loads are. You know, I'm not a trained engineer. You know, I'm just, I work on, you know, empirical data, you know, and observation, you know. But I understand engineering, and I've been at it long enough, and cabinet making and stuff, that you understand. I have a pretty good idea about loads. Feel, yeah. And if I need some help, I've called Paul before, I think, on a couple things, and it's just, you know, where you need somebody that does it for a living. This is, the other thing that I do is, like on these hubs, I'm not going to print the whole part when I test it, because that takes a long time and it wastes a lot of material. I see people on all these forums that print these entire things and it fails, and it's like, well, why didn't you print part of it? Because in the slicer now, you can section your parts and print just one little piece. So this is a baggie of tests of where I've taken a cross section out here, print both sides, and then I can check, and then I can test its strength without having to print the whole thing. Oh, yep. And then this is a leading edge connector, just standard leading edge. Yeah, thanks. But this was for one of Scott's kites, and he used, did you use an APA? Oh, yeah. Because you used a standoff, but it was too stiff. And so I just made this guy here.
Flexible for the deaf kite.
Yeah. And once again, this is TPU, and you know, really strong. And this side here is easy to remove because he wanted to remove that. The other side.
And there's no fatigue in that material on multiple
No.
Oh, that's
Nope.
fitting. Yeah, that's the T.
Yeah.
We have about 5-10 minutes.
No.
Unless you want to go forever, but other people have to go forever.
Okay.
Lindsey, are there moving parts in this, or this is just
That's
relying
it.
on the flexibility of the material?
Right.
Okay, very cool.
So this is the same material.
No fatigue.
No. Okay, so this is the TPU, the same material, all the flexible stuff is. And I'm going to show you how strong it is. Grab the knob there and hold real tight.
Not grabbing you now. Somebody has to let go.
And it will relax back. This one is a little softer than the others. This is a strap for the for the battery box on the light system. And this has, I think it's a 5,000 pound tensile strength on this. And in an XY direction, it's strong. But the TPU is almost isotropic because it's really strong in the Z. Now at the top of his kite, these are tensioning beads. Everybody's, you know, we've had these forever, but nothing that works like this. This one. And Ronnie, this is the little bead tensioner Ron would make out of ABS or Delrin.
It started originally many 30-some years ago with a hair pipe. It's called a hair pipe.
Right.
It's an elongated bead that has a hole through. They make collar things. They make
Yeah.
breastplates, whatever with that. And then you just drill the adequate holes, vertical holes. One here, one down here for the tie-off.
Right.
And it evolved to ABS or Delrin little tubes. But I wanted to come up with something with a unique shape that's easy to slide. And so I gave a sketch to Lindsey, but he took it to a whole different level. For me, it was all about just the shape of the whole thing, but with the same process. So he put recesses as the string comes up over the top and into the other hole. He put a recess in there so it would lay flat. And then instead of just a straight hole, holes through it, he put guided tunnels that when you pass the line through it, automatically it forces the line. You can make a sketch of that, of what that looks like.
Yeah, I might have it drawn out. But anyway, so I'll pass this around. Now, these fittings here we call started out with the yellow submarine because it looked kind of like a little yellow submarine. And here, oh hi Alan. Didn't recognize you for some reason. Haven't seen you forever. So, and these are for Scott Hampton, or yeah, this guy. Yeah, Hampton. And same thing here. But what he wanted is, with the tensioner, he wanted to be able to bow his kites. So this is TPU, the flexible material, and then it has a cross hole here. These are matched parts. So you just tie a loop, pass it through, weave your way on this button. I'll see if I can remember the path, and I'll draw a sketch of it. But it goes up, through, around, back down, and exits out here, and it tie a knot, and you're done. And you use dental floss threaders. And you can do these before you put the kite together, because as long as you know the length of the rod, you just add on so much line and you can make them up, you put them on, and you're
The
done.
evolution of that fitting is what's really interesting to me, and I think to most folks. And my idea was that I hated those flat metal, aluminum pieces that you buy or whatever that are hard to handle, and it's got a hook on it, you got to do this. There's got to be a better way of doing this, and that's where the bead thing and the evolution to something much more sophisticated like this,
Yeah.
or buttons or things like that.
So then at that same time, I took his ones that he makes pockets out of, and I said, well, why don't we just put it on the line? I mean, on the rod. And so in CAD, I just snipped off the ends. And once again, these have the little restrictors in, so it's not moving. But if you want to move it, you just twist it a little bit and slide it. And you can bring it out to the end. And it's kind of like doing a lark's head, tensioning with a lark's head. And this works, it's so smooth and so easy that it doesn't take anything to bow your kite. And this material here, this is PETG, so that's water bottle plastic. And that's about the best thing I found in kites to use this for, because it's slippery and it's strong. But the other thing is, when you're designing a kite, okay, so you have this nice bow here. What if you had a kite that you wanted a flat surface? You could take this and bring this down here. See if I have enough. Yeah, I'll do it on one end. And so now when you bow it, you have a flat. So you can play around with it. The other thing this is great for is if you're laying out curves for a kite, you can make your own French curve, or what did we call it in drafting?
Sailmaker's curve?
Yeah. But anyway, the other thing is that you could have a long one, and you could have multiples along here, and you could do a compound curve. No charge. Yeah.
Anybody questions? Are you
yeah.
at that point? Because we're running out of